Thank you for this question on the heat capacity equation. So the first thing I always like to do is write down what my given data is. So in this question of part A, it says water, we have 2,990 grams, is heated until it just begins to boil. If the water absorbs 4.83 times 10 to the power of 5 joules. In the heating process, what is the initial temperature of the water? So we're looking for the initial temperature of the water. That's what we're trying to find. We're going to use the specific heat capacity equation, which is this. But we're going to parse out the change in temperature. So the equation that we're going to use is change in temperature is temperature final minus temperature initial. So we're going to have to use some algebra in order to rearrange the formula to solve for the initial temperature. But in terms of the data that we have to use from this question, so first of all, we have our mass of the water, and that's in grams, which is great because the equation uses grams. If it was in something other than grams, like kilograms, we would have to convert back to grams in order to use it in the equation. We also have the amount of energy that the water absorbs, so that's our Q value, which is 4.83 times 10 to the 5 joules. We will want to convert this from scientific notation to the decimal number, because we're going to want to use that. So when you have 10 to the power of 5, that's moving our decimal over 1, 2, 3, 4, 5 places. So this is going to be 1, 2, 3, 4, 5. So 483,000 joules is the amount of energy absorbed by the water. Specific heat capacity of water we also need, and that's found in the table here. So 4.184 joules per grams times Celsius. So far we have our amount of energy absorbed, we have our mass in grams, we have our heat capacity. We're looking for TI, which means that we still have one unknown that we will need. We can only find one unknown, two unknowns, and we're not going to be able to get the final answer. This temperature final is in the equation. It said that water is heated until it just begins to boil. That's our final temperature right there, T final. And you need to know at what temperature water boils at, and that's at 100 degrees Celsius. So even though it didn't directly give us the final temperature, it does give it to us in words. So our final temperature is 100 degrees Celsius. Now we have all the data we need in order to solve our initial temperature. So what I'm going to do is I'm going to plug the data in and then rearrange the formula to solve for TI. You might want to rearrange the formula beforehand before plugging in the data. It's completely up to you. I like to put it in and then reorganize the data. So for this formula, then I'm just going to plug in the data I have. Q is that 483,000 joules is equal to our mass, which is 2,990 grams, times our heat capacity, which is 4.184 joules per grams times degrees Celsius. And then it's going to be times our final minus our TI. So the first thing I'm going to do in rearranging the formula is combine any terms that I can. So I can do this right here. 2,990 times 4.184. That's going to give me 12,510.16 times my 100 degrees Celsius minus Ti is equal to 483,000. Now what I'm going to do is I am going to bring this number over to the other side. I'm multiplying here, so that means the opposite of that is to divide. That's going to cancel those out, and whatever I do to one side using algebra, I also have to do to my other side. So now I can go ahead and do this calculation here. So 483,000 divided by 12,510.16 is going to give me 38.609, and that's going to be equal to 100 minus Ti. Now to get the 100 over to the other side, this is a positive 100, so I'm going to subtract 100 here. That gets rid of it on this side. I'll also have to subtract 100 here as well. So 38.609 subtract 100 is equal to negative 61.39, which is equal to negative temperature initial. And then to get rid of the negatives, I'm just going to multiply by a negative on both sides. That changes both sides to positive. And so my answer for my original temperature is going to be Ti is equal to 61.39 degrees Celsius. And that's going to be the original answer. Now looking at my numbers up here, 4.83 is my smallest number in terms of significant figures. So my answer should also be in 3 significant figures. So that's going to be 1, 2, 3. I have to round off this one. So my answer is going to be 61.4 degrees Celsius. It's just better if you can put it to significant digits in mastering chemistry. But if you had this answer and it doesn't accept it, then you can just let me know on the test and I will add the points in. So that's part A. I'm going to move on now to part B. So here we are in part B of this question, and it says this time that we have an unknown substance. It has a mass of 19.1 grams. When this substance absorbs 1.719 times 10 to the power of 2 joules of heat, that's going to be our energy that's absorbed. So I'm going to put that here. 1.719 times 10 to the power of 2 joules. I'm going to convert that into a decimal. So 10 to the power of 2 means I move the decimal over 1, 2. So that's going to be 171.9 joules of heat absorbed. The temperature of the substance is raised from 25 degrees to 45 degrees. That's going to be my change in temperature, which is going to be my T final minus T initial, which in this case the temperature final is 45 degrees Celsius minus the initial temperature, which is 25 degrees Celsius. So that's a change of 20 degrees Celsius. So my change in temperature is going to be 20 degrees Celsius. And it's saying what is the most likely identity of the substance? Well, that's going to be based on the specific heat capacity of the substance. So that's what we're looking for here, is what is the specific heat capacity of this unknown substance, and then we will be able to identify that from the list. So again, we're going to use our specific heat capacity equation, which is Q times M times C times change in T, and this time we're solving for C. So I'm going to go ahead and put my data in that I have already. So the amount of energy absorbed is 171.9 joules. The mass of the unknown substance is 19.1 grams. I don't know what the heat capacity is, but I do know that my change in temperature is 20 degrees Celsius. I'm going to combine 19.1 and 20 by multiplying, since I'm multiplying directly across here. And I get 19.1 times 20 is 382 times C equals 171.9. And then to solve for C, I need to bring this 382 over to the other side. It's multiplying, so the opposite of that is dividing. I'll divide this side as well, and I'll get 171.9 divided by 382 is equal to 0.45, and the units here are joules per gram times degrees Celsius. And looking over at my chart, it looks like iron is going to be the closest to that 0.45. It's at 0.449, but that would round up to 0.45. So iron would be the answer to this problem. So I hope I've helped in terms of how to rearrange the heat capacity equation to solve for the different unknowns. Thanks for watching. Bye for now.